Is one of my vacuum passes?
Yeah. All right, so this is what the equation for the tangent will look like. So it's going to be A tangent B theta, just like for the sine or cosine. So it'll be, for example, 5 tangent 2 theta. From that, we can extract the period. It'll be 180 over B this time. So this is what you have to watch for. For sine or cosine, the period would have been 360 over B. Now it's 180 over B for tangent. The asymptotes are going to be plus or minus 180 over 2B. And I'll show you exactly how that works. And we don't talk about amplitude for tangent because the range is all reals. It goes up and down to positive and negative infinity. So here we have y equals tangent of theta. The period is 180 over 1, so it's 180 degrees. Okay? The asymptotes are going to be x equals, you must say x equals. So let me do some preliminary work here. So it's going to be x equals plus or minus 180 over 2 times b, which is 1. So it's going to be x equals 180 over 2, which is 90, plus or minus. Okay? So we have 2 asymptotes, one at 90 degrees and one at negative 90 degrees. All right, so let's mark the asymptotes here. Negative 90 and positive 90. Okay? Now, this time around, these values here are going to start and end at your asymptotes. So from negative 90 to positive 90, and the rest is exactly the same. The halfway point between negative 90 and positive 90 is 0. The halfway point here is negative 45. The halfway point here is positive 45. Okay? And you do it exactly in the same way that we did it before. All right, so let's plug in our values. So again, we're going to use that unit circle. So you have, what's the coordinate here?
1, 0.
1 and 0, negative 1 and 0, 0 and 1, 0 and negative 1. Now remember, tangent this time is y divided by x. The y coordinate divided by the x coordinate. All right, so let's see what's going to happen here. Tangent of negative 90, okay? Negative 90 degrees is here. Negative 90 degrees is here. Tangent is y over x. Negative 1 over 0 gives you what? Undefined. And sure enough, it's undefined because there is an asymptote there. Okay? So what about tangent of negative 45 degrees? Tangent at negative 45 degrees, how much is that? What's tangent of 45 always? 1. Tangent of 45 is always 1. Now here, though, is tangent positive or negative?
Negative.
In this quadrant, tangent is negative. So it's going to be negative 1.
How do you know it's 1 tangent negative?
Because if you've got the 45,
Because if you've got the 45, 45, 90 triangle, it's 1, 1, radical 2. So the legs, opposite and adjacent, the legs are always equal to each other. So opposite over adjacent is always the same thing. So 1-to-1 ratio.
Okay.
All right. Now, tangent at 0 is y over x, 0. Tangent at 45, this time we're here, it's positive 1. Tangent at 90 is y, 1 over x, 0. 1 over 0 is undefined. And sure enough, it has to be undefined because you've got an asymptote there. So, at negative 45, we're at negative 1. At positive 45, you're at positive 1. And at 0, you're at 0. And you've got asymptotes there. So you do this. Okay? And that's how it looks. All right? Fascinating. All right, so next we have 3 tangent 2 theta. Okay?
You have to draw arrows on the
All right, so what are the,
ends.
no arrows necessary. What is the period here? It's going to be 180 over 2. So it's going to be 90 degrees. All right, so here the period was 180, and sure enough, between the beginning and the end of the cycle, it's 180 degrees. 90 plus another 90. So this is just going to be 90 degrees. The asymptotes are going to be x equals plus or minus 180 over 2b. So plus or minus 180 over 2 times 2.
45.
So it's plus or minus 45. So the two asymptotes are at positive 45 and negative 45. Remember, it's an equation of a line. You must have the x equals there.
Can we just write x equals plus or minus 45?
Yes. Okay, so here are the values. I've already put them here. So we go from negative 45 to positive 45. The halfway point is 0. Now, halfway between these two is negative 22.5. Halfway between these two is positive 22.5. Okay? All right. So here we're going to have 3 tangent 2 times negative 45. 3 tangent of negative 90. So again, what is tangent of negative 90? That's this point.
It's undefined.
1 over 0 is undefined. Okay, here I have 3 tangent of negative 22.5 times 2. So it's 3 tangent of negative 45. All right, now, tangent of 45 is 1. At negative 45 here, tangent is negative 1. So this is going to be 3 times minus 1, 3. Okay? All right, here I have 3 tangent of 2 times 0, which is 3 tangent of 0. At 0 degrees, what's the tangent? 0. Okay, next I have 3 tangent of 2 times 22.5.
Yeah, I have a question.
3 tangent of 45.
How is it 3 not negative 3?
Oh, it's negative 3, thank you. Negative 3. But here it's going to be 3 times, tangent of 45 is 1. 3 times 1 is 1. 3. Okay? Next we have 3 times tangent of 2 times 45. So 3 tangent of 90. And that's undefined. Alright, plugging them in at negative 22.5, which is here, we're at negative 3. And then at 0, we're at 0. And then at positive 3. So it's going to look like this. So you see what happens between this and the first one? We added a factor of 3 in the beginning here. And what happened to the graph? It got flatter. Do you see it? So that's what the 3 does. It makes it more steep. Just like in the case of parabolas, it makes it more steep. Okay? Okay.
So you can't really see that it becomes a parabola.
We've done sine. We've done cosine. We've done tangent. We've got now secant, cosecant, cotangent. This is important. You want to focus for this one. Sine and secant, sine and cosecant are inverses of one another, right? So 1 over the sine is the cosecant, 1 over the cosine is the secant, and so on. So to graph cosecant, here's what you do. You graph a sine function, okay? You break it down wherever the sine function is 0. Cosecant is 1 over sine, so it's going to be undefined. So wherever the sine function is 0, you're going to have asymptotes, and the cosecant is going to be these parabola-looking shapes above and below the maximum and the minimum. Okay? So let me talk about that one more time. If you want to graph the secant, that's 1 over cosine. You graph cosine. Wherever the cosine is 0, the secant, which is 1 over cosine, is going to be undefined. So that's where you have your asymptotes. And then you have these shapes on top of the maxima and below the minima. Okay? The cotangent flips altogether, as you can see here. Okay? All right, so let's do a couple of examples here. All right, so here we have the period and the amplitude of each function. So what we want to do is, if you're going to graph the secant, that's related to the cosine, you first graph the cosine. So this is not a typo. You take the cosine function of it. Now, I'm not going to worry about amplitude. Let's talk about period. What is the period of this function here? It's 360. Remember, cosine and sine are 360 over pi. 360 over 1 over 3. So that's 360 times 3 over 1. How much is that? Anybody? 1080. So here we're going to have 1080, and here we're going to have 0. All right, the halfway point is how much? 540. The halfway point here is 270. And the halfway point here will be how big? 7, 8, 10. Okay?
And the amplitude is.
We're not going to worry about the amplitude for now. Okay, so let's plug in these values into the cosine here. Here I have 2 cosine 1 over 3 times 0. So it's 2 cosine of 0, which is 2. Cosine of 0 is 1, times 2 is 2. Next, 2 cosine 1 over 3 times 270. This is 2 cosine. What's 1 over 3 times 270? 90. Cosine of 90 is 1. I'm sorry, cosine of 90 is 0, so this is 0. Okay, 2 cosine 1 over 3 times 540. This is 2 cosine of 180, negative 2. 2 cosine 1 over 3 times 810. 2 cosine of 270, 0. And here, we're going to get positive 2. Okay, so to graph this, I'm going to modify my axes one more time. I'm going to make this 1080, and this one 540, and this one 810, and here 270. Okay. At x equals 0, we're up at 2. At x equals 270, it's 0. 540